I am Mini, EC Department from Emmanuel Arasar JJ College of Engineering. Now, I am going to explain about the topic differential pressure transducer using strain gauge. First, we should know what is meant by transducer. What is meant by transducer? It's a device that converts a physical quantity into electrical signal. That means converts one form of energy into another. The energy may be electromagnetic or electrical, mechanical, chemical, acoustic, or thermal, etc. Okay. For example, if we consider microphone is a transducer. Here, the physical quantity is sound, it will convert into electrical signal. If we consider pressure as a transducer, pressure is converted into electrical signal. Next, we are going to see about differential pressure transducer. That is, it's a sensing device that measures the difference between two pressures, which may be indicated as P1 and P2, and converts it into an electrical signal. From the name itself, we will easily understand this because differential pressure transducer, that means difference in pressure. Okay. First one, fluid coupling. Inlet ports for high pressure P1 and low pressure P2. That means inlet ports means opening or entry point through which fluid, maybe air, gas, or liquid, enter into a device or system. Simply, these inlet ports allow the pressure or fluid to enter the instrument. Uh, for example, water entering a pump or air entering an engine or otherwise pressure entering a pressure sensor. The next one, flexible diaphragm. It is used to separate the two pressure chambers. Actually, this flexible diaphragm is a thin elastic membrane that bends or moves when pressure is applied. That means it changes its shape when pressure acts on it. But in differential pressure transducer, it separates two pressure chambers. When it separates, there is a pressure difference. The diaphragm deflects. This movement is used to produce an electrical signal. Then the third one is plastic dome. Plastic dome is a protective curved cover made of plastic. It protects sensitive parts from dust, moisture, and direct fluid contact. It is used to protect the sensing element from contamination. Then the fourth one is armature. Armature is a movable mechanical part that transmits moment of force from one component to another. It actually here it transfers the diaphragm moment. Then the fifth one is strain gauge. Strain gauge, what is the purpose of strain gauge here? It's convert into mechanical strain into resistance change. Strain gauge is a sensing element that measure the strain. Strain indicates that stretching or compression. Here, the strain gauge convert the mechanical strain into resistance change, which means when pressure is applied, the gauge stretches or compresses. Due to this, the value of resistance is changed. Therefore, the changing resistance is proportional to the amount of strain. The next one is rigid frame. So, rigid frame is a strong, non-flexible supporting structure. It supports the strain gauge. How it supports? To provide the mechanical support without bending. Okay. Then the last one is cable. It carries the output signal. Here, first, whenever the pressure difference created, the diaphragm will deflect. This we know what is mean by diaphragm that we discussed already. This diaphragm movement is transferred to the armature. This armature transmits the moment of force from one component to another. Here the armature produces strain on the strain gauges. This strain gauge change their electrical resistance. Here we are used Wheatstone bridge. What is the purpose of Wheatstone bridge here? That is converts the resistance change into a measurable voltage. Then the output signal is sent through the cable to display or control systems. So simply we remember this differential pressure transducer measures the pressure difference, not absolute pressure, isn't it? In the strain gauge, here strain gauge principle is used here. The output is the electrical signal which is proportional to the pressure difference, which may be represented as del P. So I think you all understand. So next we go the applications. What are the applications of some of the applications of differential pressure transducer is it's used to flow measurement, level measurement, filter monitoring, and industrial process control. I think you all understand. Thank you.